Alright, this is a video demonstration of the Cincinnati model R75 cylindrical grinder. This machine has a pick feed cycle as well as a plunge feed cycle. It's universal in that the herc head can be swiveled to a certain degree, as well as the wheel head has a certain amount of swivel to it for certain applications. You have your tailstock here, the wheel head. This is your in-feed indicator for plunge grinding. Basically, we'll start the machine. Start the hydraulics and the grinding spindle. And a basic program, automatic program, would be to cycle start. We move in and we start to feed down in a plunge grinding mode until we get to the fine feed and we stop until we get to 0. Now that represents about 6 or 7 or 10 thousandths that you can take off your workpiece. Your first piece, the machine has to be set up by hand using the in-feed hand wheel, and once you get your piece to the final size, then you set your dead stop here and then back it off so that you have your 5, 6, 7, or 8, whatever thousandths that you need to actually remove from your workpiece. That's what you see up there. And we come down to 0, and there's a spark out timer mounted on the side of the machine. You can adjust for the time. So that's a typical plunge grinding operation. When you're going to do traverse grinding of a long shaft or left and right grinding, the machine can do that also. We have to shut the plunge off, and we turn our table on. And now when we come in, we start our table to move. And in this instance, you have a feed that's going on down here, a mechanical feed. Now if you notice your in-feed indicator, it's gone and fed all the way down to 0, but the lights aren't on. This is at its fine. This is at the dead stop of the in-feed mechanism, and we're working solely down here with the hand wheel. This is the way you would use it by hand also. You would take the automatic feed off, which causes the feed to feed completely out to its dead stop for accuracy. And then you have your in-feed with your, either by hand with the hand wheel or with the automatic mechanism. So in this style of grinding, when you get to 0, you basically have to spark it out by your own judgment and then retract the grinding operation. Over here we control the amount of in-feed, the rough feed, and the changeover to the fine feed, and we control the speed of the table as well as a dwell. If you wanted to include a little bit of a time delay at each reversal, you have that ability. The workhead here, if you work around this way, this is a variable speed drive. As you turn this while it's running, you get to go slower or faster. This is going slower as I turn it. It goes from about 60 RPMs up to 500 RPMs. This, I believe, is a Morse taper number 4, and this is a Morse taper number 3. Again, put the machine in the automatic mode, and I'll stop the table, and we could just do a straight in plunge. So again, you watch your needle come down. Your fine feed. And of course, at the end of this, if this wasn't the right size, you would make a fine adjustment here with the hand wheel. If you found out that you were a tenth or 2 or 3 too big or too small, you make your fine adjustment here. All this unit on the top nose is to feed out to its dead stop in a coarse and then a fine feed. So the actual adjustment of the actual size of the part is done manually by the operator to get it to the right size, and then this hand wheel is no longer touched. And that's it. These machines are made in Germany. Pretty robust. Takes a 14-inch, I believe, size grinding wheel with a 5-inch bore. I believe it's 14, possibly 16, but I think it's 14. There's a coolant system for it that sits at the side. The hydraulics are mounted at the rear, and the electrical cabinet is mounted on the side of the machine.